Good morning, everyone. I'm Fabiola Rocatagliata. Happy to say you welcome to the webinar, the first webinar of the COSMOS project. So we prepared a brief agenda for today. Basically, I'm happy to start the presentation, give you a brief introduction, and after that I will leave the floor to Anastasios, colleagues from CO2 Value Europe, that will give you a brief overview of the situation in Europe about the CO2 valorization and policy framework and perspective. And after that, I will happy to leave the floor to Raul from Cartif, the coordinator of this project. And then I will leave the floor to Robert from Avantium Support BV. That is the one of the demo that this project has. And he will give us a brief overview of the demo and the status of the activity that they want to perform. And after that, me and Miriam from ERA, me from Arena Consulting SPA, we want to give you a brief overview of the activities that we are performing in Work Package 1, and basically why we are organizing this webinar and also other webinars after this one. And after that, we prepared a brief poll with three simple questions for you, only to be sure that you like the webinar, you are interested in the project. And also we give you the floor to ask us some questions. So please use the dedicated panel in the GoToWebinar application to ask us some questions. Online there are the speaker, but also there are the consortium. So if you have any question for someone of us, please ask and we try to answer. So with me today, there are the speaker. So as I said, I'm Fabiola Rocatagliata, I'm working in RINA, and with me there are Anastasios from CO2 Value Europe, Raul, the coordinator from Cartif, Robert from Avantium, and Miriam from ERA. So thank you very much to join the webinar. Enjoy and see you later. So thank you very much, Anastasia. I will leave the floor to you. So are you now the presenter? So you can share your screen.
Thanks, Fabiola. Just putting it on. Please confirm that you can see it.
Yes, we can see in presentation mode. So thank you very much.
Perfect. So good morning, everyone. My name is Anastasios Perimenis from CO2 Value Europe, one of the partners of COSMOS. Obviously very happy to be here on the first webinar of COSMOS, and at the beginning also of the project. The project has started in May, so it's a rather young project. And before going to the description of the project by the coordinator, I would like to spend a couple of minutes to situate it in the context, in the European context. And this is what I will do in the next 10 minutes. So maybe basic information, but still important to mention it. The project is about carbon capture and utilization, in this case biogenic CO2 emissions from the bio-based industries. And what is CCU after all? It's a circular process in principle, starting from CO2 either captured directly from the air or from point sources from industrial installations, with the use of renewable energy and through the application of an array of technologies, we can produce an array of different marketable products, be it fuels, chemicals, materials for the construction sector. So through this process, we can achieve emission reductions. We can even arrive to negative emissions depending on the pathway. But we also provide an alternative carbon feedstock to the industry. There are not many possibilities for an alternative carbon feedstock beside the conventional fossil feedstock. You have biomass with associated sustainability constraints, you have recycled plastic, and then you have CO2, which can be a sustainably scalable option because there is a lot of it out there. And through these circular approaches, we increase circularity and industrial symbiosis. We make our industries more sustainable, more resilient to changes. And of course, we contribute in the expansion of the renewable electricity into different economic sectors. So this is the general idea of CCU. And CO2 Value Europe, for those who don't know us, are the European association that is representing the CCU community. And we are bringing together stakeholders from the complete value chain of CO2 valorization, from upstream, from CO2 emissions, the use of raw materials and waste, the use of renewable energy to transform, to convert the CO2 into different products and distribute those products. So you will see in our membership different from multinational companies to SME technology providers for the CO2 conversion, regional clusters, universities researching the CO2 technologies, and so on. So our vision is to make CCU a pillar of the transition to a more sustainable economy, and as a part among all the other options that we have, electrification when it makes sense, increasing process and efficiency, use of hydrogen, storage, biomass use, renewable energy expansion. So all of these options should be considered in trying to transition to a more sustainable economy. What we do and what we do will be for the benefit of the project also of Cosmos is we are trying to be a hub of collective intelligence. You see an example here from our database on CCU projects of higher TRL also, and how many of them are for the conversion of CO2 to fuels, or simply capture projects, or projects, for example, for mineralization for the production of construction products. Another thing that we do, and it falls right into today's webinar, is our own participation in EU projects. So not only in the sense of bringing partners together to develop projects and help with get funding for those projects, but also our own participation. Impacts 9, for example, is the European projects, the operational arm, if I can say it like this, of the CCUS set plan and the strategic energy technology plan that recognizes CCUS as one of the priorities for clean technology deployment. Initiate is a project that aims to produce urea from steel off gases. Takeoff is a project that aims to produce sustainable aviation fuels from CO2, and Cosmos and Vivaldi, the two sister projects, are using CO2 from bio-based industries to produce an array of chemical products for the chemical industry. So in all those projects, we are the communication and dissemination work package leaders, and benefiting from our network to disseminate the information of those projects to a broader audience. So why we're doing Cosmos, why this project? I think it's more or less evident to everyone. The climate emergency, the goals that the European Union has set for 55% emission reductions by 2030 and for climate neutrality by 2050, leads to the fact that emissions should be reduced, emissions should be used, and even reach to negative emissions, so that we can arrive to the well below 2 degrees scenario. So this is the driver of the projects, using emissions, in the case of Cosmos, also emissions from the bio-based industry, so biogenic emissions, so that we can avoid the appearance of new emissions, and lead also in some cases to negative emissions. And CCU has an important role to play there, and science is there to back the claim, to back this claim. I'm stating some examples of how CCU can contribute to mitigate climate change, and especially now, since Cosmos is related to that, especially in the chemical industry. With a few examples, you can click behind the image is the identifier and the link to the study. And I'm stating some examples from Kettleton, for example, that said that CCU has a technical potential to reduce annual greenhouse gas emissions in the chemical industry by up to 3.5 gigatons of CO2 equivalents in 2030. And other studies also show the potential of CCU to reach climate goals, greenhouse gas emission reductions in the years to come. So the more we advance in this area, the more life cycles assessments and environmental assessments will be out there, also fortifying and increasing the confidence of operators in the potential that CCU has. So all this is situated within the European Green Deal, which is a huge, let's say, package of actions that will operationalize and will help us achieve EU's climate goals. It has 3 pillars: the planet, the prosperity, and the people. So no one should be left behind. Economic growth decoupled from resources use, and no net greenhouse gas emissions by 2050 in Europe. And there is an array of legislative also instruments that will help us, will guide the way to achieve the goals that the EU Green Deal sets. And it concerns almost every economic sector, in agriculture, in industrial activities, transports. So in principle, all economic sectors that are of relevance to this goal. I would like to spend the last couple of minutes just to point out that, as you know, in July, we had the Fit for 55 package from the Commission with an array of new instruments, or instruments that were revised exactly to be fit for the purpose of 55% emission reduction. And some of them are the revision of the emission trading scheme, the Renewable Energy Directive, the Refuel EU Aviation that sets new goals for synthetic aviation fuels, Fuel EU Maritime, or the Energy Taxation Directive. I would like to focus only on one of them, on the Renewable Energy Directive, which is interesting for our purposes here, is because for the first time we see a goal being introduced for the use of renewable fuels of non-biological origin, which is a fancy word for CCU fuels or CCU projects. And interestingly, these are for energetic and non-energetic use. So for the first time, CCU products like the one that Cosmos will produce find their way into policy by having a share of their use in the industry. So 50% of the use of hydrogen in the industry should be covered by such products, which opens up the market also for CCU products like the one of Cosmos in the chemical industry, and that being recognized. So with that, I would like to close this. I will give the floor to Raul to explain the technical details behind Cosmos, I'd like to express again our enthusiasm for starting this project and for working with the consortium for the next 4 years to bring it to a fruitful completion. Thank you very much.
Thank you very much, Anastasis, for your presentation. Raul, we can leave the floor to you. Now I think you are the presenter, so you can share your screen. Thank you very much.
Okay, thank you. Thank you so much, Fabiola, for your kind introduction. Also, thanks so much to Anastasios for your very interesting presentation. First, I want to confirm that you see my screen, full screen presentation. Can you see it?
Yes, perfectly.
Right. So we can start now. Good morning, everyone. My name is Raul Piñero from Cactus Technology Center, and I am the person of coordinating the COSMOS project. Well, first, I would like to thank everyone for your interest in participating in this webinar. It's my true pleasure to present to all of you the project for this very first time in public. So as I know that this is your first contact with COSMOS project, and I want to give you a very good impression, I have prepared a very brief summary of, well, including some relevant ideas, fundamentals, some technologies, and final applications that we are going to address in this project. So let's go directly to the presentation, to the introduction of the consortium. Let me introduce the big team we are working in this project, led by Cactus Technology Center as a coordinator. We count with a wide expertise and high interdisciplinary of 15 international partners, ranging from technology developers such as Cardiff, CSIC, Funditech, Sintef, University of Twente, and University of Amsterdam as our research and technology organizations. We are also supported by the Biobase Europe pilot plant as an SME expert in bioprocess and biorefinery upscaling and pilot plant validation. And we count as well with CO2 Value Europe as a European association representing the carbon capture and utilization community in Europe. We count as well with very good interdisciplinary research institutes, experts in circular economy and sustainability, such as the Center of Research and Technology of Greece and Aachen University. Also, Rina Consulting, which is organizing this event, will provide us technical services and engineering tools. And finally, very important thing is the industrial end users representing the bio-based industry sector with Avantium, Novamont, and Nadir. And last but not least, we count as well with a group as a big company expert in waste management and transfer of technology. So this is a very brand new project. We started in May, and we are just developing the different tasks and technical parts of the project. Okay, before going to the main technical part and concept of the project, maybe it's a good idea that we raise a question. What are the biogenic CO2 emissions? Can they be considered a problem or an opportunity? Well, the answer is probably both. So first, you can see that we have 3 types of biogenic CO2 emissions, depending on the origin. We can consider basically biogenic CO2 coming from industrial sources, which are processes that are based in fermentation. And this is a very important part of the CO2 emissions in the chemical industry. And this project, COSMOS, is focused on taking advantage of this specific CO2 source. Why? Because the characteristics of these streams, because of their high concentration and other parameters, make them very suitable for the conversion into added value chemicals in a cost competitive way. So industrial sources based on fermentation processes are our main, let's say, sector that we address. Also, it's very important for us to keep an eye on the waste treatment plants that they represent a very relevant amount of the CO2 emissions that are emitted to the atmosphere. And this is part of our replicability and further case studies that we are going to consider in order to extrapolate our results and to replicate our results to other sectors which are not specifically the bio-based industry. So, okay. Now, the question is, are CO2 emissions an opportunity? Well, yes or not yes. The answer is yes. If we are able to use CO2 as a carbon and oxygen source to convert it into high added value products and in an effective and sustainable and cost competitive way. Okay, let's go to the COSMOS concept project. As you can see, we start from an issue, the generation of biogenic CO2 from different sources. You can see this is a huge amount from different sectors, bio-based industry, biogas production, and so on. The aim of this project is to develop a full platform of technologies which can address the recycling and the conversion of this CO2 into a long-life, sustainable chemicals or bioproducts in general. This is of strategic importance for the future of the European bio-based industries, of course. So the solution that we present in COSMOS is to develop a set of innovative and cost-competitive CO2 conversion technologies to transform these biogenic CO2 emissions produced basically by bio-based industries into a set of high added value chemicals with direct use as intermediate materials for bio-based products within the bio-based industry. We are talking about biopolymers and renewable chemical sectors specifically. You can see here in this figure a very basic sketch of the concept and the flow diagram and methodology of the project. So basically, we start from the biogenic CO2 sources that are coming from industrial fermentation plants. Then we develop different conversion technologies. You can see that we are going to address 3 technologies: biological conversion, electrochemical conversion, and green chemical conversion based on organic catalysts. Using these technologies, we can produce, let's say, 2 basic bulk chemicals or material vectors that can be used as a starting point to develop a whole biorefinery. These target molecules are acetate and gas of synthesis. From the different processes we are going to develop, we can transform these bulk chemicals into intermediate chemicals that can be considered as building blocks for the chemical industry. We aim to produce PHA, PHB, long-chain decarboxylic acids, and 2,3-butanediol. We are going also to produce hydrocarboxylic acids and aromatic compounds, and as a last product, we are going to produce cyclic carbonates. All these intermediate materials will be used in the formulation of different end products in specific sectors, basically the polymer sectors. We are talking about biopolyesters and biopolycarbonates, and in principle, different kinds of biopolymers and biodegradable materials for different sectors. As you can see in food packaging and applications, food packaging, fashion industry, biochemical industry, automotive industry, and so on. So the solution we propose is also based not only in the technology development, but also in a study of economic parameters in order to make these technologies fully scalable, and in order to be sure that we can replicate these results in the industry. We are going to use different tools. We are going to use, for instance, techno-economical assessments, life cycle assessments, other tools addressing social acceptance, and so on. So you can see here that talking about the parameters of sustainability which are very, very important for the success of this project. We are thinking about synthesis of long-time bioproducts, easy to recycle, negative CO2 emissions processes, renewable materials and energy sources, such as green hydrogen, which is, of course, this is mandatory for CO2 conversion, and maximum replicability on bio-based industry by mapping CO2 emissions from different bio-based industries and biogenic CO2 in general. Well, let's talk about the technologies, specific technologies we are going to develop from the laboratory to the pilot plant scale, with some results about the pre-industrialization that can be covered for the end users. First technology we are going to address is the biological conversion of CO2 plus hydrogen or syngas into C2 and C4 compounds, basically acetate and 2,3-BDO. We are going to address one specific technology for biotransformation of CO2 into acetate by means of gas fermentation technology, and we are also going to tackle the conversion of CO2 from syngas into acetate and through 2,3-BDO compounds. So basically, we have two lines. One is working with CO2 plus hydrogen, and the other one is working with a gas of synthesis. That you know, this is a mixture of CO2, CO, and hydrogen. Another technology we are going to implement in this project is electrocatalytic conversion of CO2 and water into green syngas into added value products. So we are going to perform a very innovative and very competitive electrocatalytic reactor for the conversion of CO2 and water into green syngas. And we are going to develop a very innovative technology for simultaneous polyols oxidation and CO2 reduction into syngas. Then the rest of the technologies are more focused on production of intermediate materials. So we have in technology 3, the chemical conversion of CO2 into cyclic carbonate by organic biocatalysts. This is, let's say, the third type of the technology that we are going to implement. And then we are going to transform these building blocks into intermediate chemicals. This is the aim of the technology 4, the biotransformation of acetate into different bio-based industrial products, such as PHBs, PHA, decarboxylic acids, and 2,3-BDO, as I mentioned. And finally, we are going to develop a catalytic membrane reactor for syngas conversion into aromatics. So this is a picture of the 5 technologies that we are going to develop in the project. Okay, this is let's say, an scheme of the integrated process and technologies for the CO2-to-chemical platform. CO2SMOS project aims the upgrading of CO2 emissions from relevant bio-based sectors by means of a sequential conversion technologies will reduce energy consumption. To this end, a cascade conversion process is produced based on a primary conversion of biogenic CO2 into bad chemicals with the 2 technologies I mentioned, gas fermentation to acetate, and direct electrocatalytic reduction, either to syngas or to syngas plus glycolic acid or lactic acid. Then we are going to use gas fermentation that will be applied for obtaining acetate from syngas, which will be used as a bio-based renewable feedstock for producing bio-based chemical intermediates. Then we have a second step, which is the production of the added value chemicals. Here, technologies are include to produce added value bio-based chemicals such as organic catalyst conversion to silicon carbonates, or which can be previously obtained from plasma chemicals. We can also address liquid fermentation or acetate to bio-based chemicals, syngas fermentation into 2,3-DBO, etc. Well, finally, once we have obtained all these biointermediate products, we are going to validate the application of these materials into end-user applications in different sectors, but basically focus on the renewable chemical sector and the polymer sectors. So we are going to validate the whole process by producing end products, specifically biopolyesters, biopolycarbonates, and other kind of renewable chemicals. In this project, the very innovative thing is the production of the bulk chemicals and intermediate materials, which are based on CO2. So the final aim is to produce these chemicals by a low carbon or negative carbon technology, also cost competitive and efficient. Okay, just as a summary, the aim of Cosmos is to develop breakthrough and cost-effective routes to produce high added value chemicals from bio-based industrial CO2 emissions, especially focused on biogenic CO2 and renewable sources such as green hydrogen and biomass, by means of a solution that combines innovative biotechnological and intensified chemical conversion processes. This solution comprises a multi-stage gas liquid fermentation cascade process, a co-electrocatalytic technology and catalytic membrane reactor system, and a biomass conversion process driven by organic biocatalyst. The project will tackle the development and optimization of a CO2 conversion technical toolbox, allowing for the production of 7 added value chemicals and polymers: PHA, PHB, 2,3-butanediol, long-chain dicarboxylic acids, BTX, cyclic carbonates, and hydrocarboxylic acids. And these products will be produced from the primary conversion of CO2 into 2 platform bulk chemicals, syngas and acetate. So the proposed technologies will be tested and validated from the lab scale to the pilot plant scale. And the obtained molecules will be validated into final applications for the formulation of high-performance biopolymers and renewable chemicals. Well, in this picture, you can see a basic methodology of the project. You can see that all the tasks, technical tasks and activities are organized in a horizontal way and vertical way and divided into 5 main phases. The phase 1 is focused on the preparatory activities. So we are going to deal with the definition of the value chain and key performance parameters. We are going to develop the mapping of CO2 emissions and as a preparatory actions for the CO2 conversion processes. We are going also to deal with the management of the biofeedstock that we are going to use for the development of the organic-based catalyst. And we are going to develop other strategies such as engineering of microorganisms in order to optimize the performance of the biological processes. In phase 2, we are going to address the optimization of the technologies at the lab scale. Of the 5 technologies I already mentioned, so I don't go to get into more details. Phase 3 will phase the process upscaling and pilot plant validation, specifically focus on the 5 technologies we have mentioned. So the idea is to bring these technologies from the laboratory optimization to the pilot plant scale to validate experimental protocols and then produce all the engineering or all the technology data that is required for making this process feasible and reliable. Once we have complete this phase 1, 2, and 3, which is the very core of the project, we are going to use these CO2-based products for the final formulation of new base products. So in here, we are also going to deal with a laboratory test and pilot plant standardization and end products formulation. Phase 4 will be tackled by the industrial users. As you can see, Novamont, Avantium are the leaders of this part of the project. And finally, phase 5. Well, it's like a closing, a kind of validation of the whole process and technology. In here, we are going to focus on the full value chain evaluation. We are going to work about regulatory issues and health and safety analysis. We are going to live with techno-economic analysis and integrated process design, market analysis and business models, environmental assessment. So all these tasks and ideas are integrated in the project and also impregnated with the horizontal activities, which are very important for the diffusion, for the communication, for the analysis of the social readiness and acceptance of these products, for the integration and potential symbiosis with other industries. And of course, which is very important at this moment, is to try to engage the stakeholders and industrial partners that can be interested in this technology, not only for the technology from the point of view of the technology itself, but also for future application and activities that everyone can take benefit from. Well, you can see here some of the facilities that we are going to use along this project. As I mentioned, from the laboratory plant to the pilot plant scale, and finally some facilities for processing of biomaterials in real industrial sites. Well, just to finish, because I don't want to get too longer, I think it's very important to leave some time to the other speakers. I would like to bring your attention about the expected impact and potential benefits for the industrial sector around this project. So the question I want to answer is how Cosmos technologies can enhance the industrial vision regarding circularity and regenerative capacity of the biogenic CO2 emissions and looking at added value chemicals. How? Well, the first, I think the most simple way is to pay attention to the expected impacts of the Cosmos results. So just to be very synthetic, I think that we are going to develop a whole platform of technologies and processes that aim at reducing the dependence of non-renewable resources, mitigating the climate change, and strengthening the European competitiveness and creating jobs. All these, let's say, final results or expected impacts are totally aligned with the European policies, with the strategic agenda, and with the bioeconomy strategy, CO2 conversion strategies, and so on. So we think that this project is fully committed to reinforce this strategy and not only give a good support and a good future for the bio-based industry to reinforce the role in the industrial sector, but also to comply with the environmental targets of the European Union. Some very specific impacts that have been set as targets in Cosmos project. As you can see here, we have listed from 1 to 5. Basically, development of technologies for conversion of CO2 into high added value chemicals, design of integrated processes with zero or negative greenhouse gas emissions, which is very important and very innovative and breakthrough and challenging in this project. To create new business models and value chains in the CO2 utilization sectors, to define targets for conversion processes, including energy requirements, production costs, and product yields, and finally, to improve the diversification of the economic base of the bio-based industries. So this is all I want to try to explain to you in the best way I can, and hope that this first contact with the COSMOS project and with the ideas and the targets we have it's going to be very interesting for all of you. And well, just to say thank you so much, and let's keep time for the next of the speakers to continue with the webinar. Thank you so much. Okay, Fabiola, the floor is yours. Thank you.
Thank you, Raul, for the great presentation of the project. A long presentation, but I think it is important to highlight everything, also to show to the audience the importance that this project has. So thank you very much. Now I'm happy to leave the floor to Robert from Avantium to briefly explain one of the demos that we have in this project. Just a second, Robert, that I try to make you as a presenter. Okay, the floor is yours.
So, can you see my presentation?
Yes, thank you.
Oh, wait, something's going on here. Yes, okay. Good morning, everybody. So my name is Robert Jan van Putten. I work at Avantium already for a very long time. I'd first like to thank the previous speakers, Anastasios and Raul, for their nice introduction to the project and also to the topic of using biogenic CO2 as a feedstock for future chemicals. In my talk, I'd like to explain a little bit why Avantium is in this project and why it is interesting for us, and also more, since within this project we mainly work on polymers, I will try to explain it from a polymers materials perspective and show a little bit on what the focus is on what we will do within this project. So just a little bit about Avantium's polyester research. So for years, about 15 years, we have been working already on PEF, polyethylene furan decarboxylate. This is what some people may know our company of. And that project at the moment is in the design phase for a demonstration plant. This work is not related to what we do within the COSMOS project. That is more related to our other polymer research, which we do in the Avantium corporate technology group, in which I am a senior scientist. And in this group, we work closely together with the University of Amsterdam, but also other partners like LEGO to develop novel sustainable polymers. We look at CO2-based, recycled-based or bio-based monomers to develop new polymers that are sustainable and that fit the purpose, so to design polymers towards the purpose. And the current market, it is mainly, there are 5 big polymer types, and they are used for almost all applications, and often they try to adapt these polymers a bit or the application a bit to fit these relatively inexpensive bulk polymers. So it is a completely different philosophy, basically. And as I said, we work closely together with the University of Amsterdam, so we also have PhD students in our group, and this is a very inspiring area to work in, and also with young researchers. So here I have a short overview of the problem statement towards the non-sustainable plastics. At the moment, there are 2 main issues related to this. So the first one is global warming, as Anastasios already explained. This is a big problem, since all plastics essentially that are currently produced are fossil-based, and a lot of these are. So there are either 2 problems: either we burn them and then it ends up as CO2, or they get littered, and then there is the waste problem that we see in terms of the plastic soup and related problems for the environment. Then also the question is, how did we get here? Because especially the last 15 years, we've seen an enormous explosion of this pollution issue. And what we see is that there's an enormous increase in consumption. So, the expectation is if we go this way, we will be producing even 3 times as much plastics as we're doing currently by the year 2050. And at the moment, we can already not handle this enormous production in terms of waste management and also CO2 output. And if you then look at this plastic market, we see that most plastics are extremely cheap to produce. So we're talking here about $1 to $2 per kilogram of bulk plastic. Plastic like PET, last year the price even dipped to way under $1 per kilogram, which is really very inexpensive to produce. This means that this market has a total value of somewhere around $400 billion per year. To put it in perspective of how many people live on the planet, which is about 7 billion, we're producing about 50 kilograms of plastic per person, and we spend, and depending on where you live, anywhere between $50 and $100 per person per year in plastics, which for especially wealthier countries actually is not that much money, but yet we have a huge pollution problem that is very costly. And also what we see is that the growth of the production of sustainable plastics is actually not as fast as we would like, because the growth of the market is faster. So the amount of sustainable plastic produced is really low. It's not more than maybe 1-2%. And then last week, there was an interesting report, or maybe 2 weeks ago, from the World Wildlife Fund, which made an estimation of what this plastic pollution costs us. So the expectation is that it costs somewhere around $4 trillion per year, which is about 10 times the market size of the total plastic market, which is extremely expensive. So the story that we can't compete because any sustainable solutions we find are too expensive is actually not a very strong argument, because if we keep going this way, you can imagine this is so expensive that we cannot afford. So the important message I would like to give, also from an economical point of view, is that we cannot afford to be non-sustainable. We need to do something. And that's why it is very important that the political movement, but also something like these projects are funded by the European Union to develop technology, as they are at the moment the market is still almost completely filled up by non-sustainable plastic. So what do we consider sustainable then? As Anastasios already mentioned, you can get carbon from either biomass, CO2, or chemically recycled materials. This is the carbon that is already above ground, and we would not like to keep getting carbon from below ground, from oil or coal, to produce our materials. So, and then the next question is not about the CO2 output, but about the durability and the degradation and the waste littering issues. Is that we should probably design materials more to reuse them, because if you reuse something, let's say 10 times, if I could have a plastic bottle, I can reuse it 10 times. I only need 10% of the virgin material to make it, and then I need to wash it. And this also means that there should be a change in the design of the materials, because many of the current bulk plastics that we use are not fit for that, because their temperature resistance or their chemical resistance is not good enough. Apart from that, we have to always think about, okay, even if we make a very good reuse system and have very good recycling and waste management infrastructure, there will still be waste. A few years ago, we went with some colleagues in Amsterdam. We went through the canals, and they have organized plastic fishing trips. And so boats go all day through the canals in Amsterdam with people going on these plastic fishing trips. And yet, every time you find a few bags full of plastic to throw, so they end up in the environment, even though we have a pretty good infrastructure for waste management. When you think of this, you should also think that at some point these plastics should be degrading. Otherwise they will just stay around effectively forever, because for most of them it takes hundreds of years or something to degrade, which is way past the normal lifetime. So even if we improve our sourcing and we do not do anything about this, we will still be building up plastic waste. But the question of, okay, how degradable should this be, and can we tune this, is still very very complicated, because we don't know so much about that yet. But some of our research shows that we can make different plastics that are degradable. But then the question is, can we tune this? Huh? So can we fix how degradable something is? And then something about sustainable monomers. Now, if you look at these, I just picked a couple that are interesting, some that we are working on. If you look at the structure and you compare it to what is normally the case for monomers in the plastic industry, the first thing is that there's lots of oxygen in the rings, or oxygens and ring structures, and this gives the, if you incorporate these in polymers, it gives them different physical properties. I just see that I made a mistake with the glycolic acid. Oh wait, no, it's not. It's just something in my screen. And within this project, we will mainly work on the 2,3-butanediol. And these monomers can give properties to polymers that are completely different, or often improved from what we are used to from oil-based polymers. Also, we as a company mainly work on, or actually only work on, what they call condensation polymers, which are much more suitable, especially for chemical recycling. So condensation polymers are, in this case, mainly polyesters. One interesting thing is what you see here. There are some what we call secondary diols. This means that if we can incorporate those in polyesters, we can make more rigid structures. So if you look at advantages of using sustainable monomers / polymers, is, like I said, you can use different properties. It makes much more sense to look at, okay, what interesting monomers can I make, and from these monomers, what polymers can I make, than to try to make the existing polymers, which are mainly polyethylene and polypropylene, from biomass or from CO2, because then, as I showed, there's lots of oxygen in these structures. If you want to make these other polymers, you have to take out all this oxygen, and that means you have to reduce mass, which costs often energy and a lot of money, and it reduces the value of your product. Or it actually increases the cost of the process. So it doesn't really make a lot of sense. It's like trying to put a square peg in a round hole. It just doesn't fit very well. And as I said, we look a lot at secondary diols, which are typically difficult to put into polymers and polyesters because of their lower reactivity. But the advantage, if you put them, is you can make more rigid structures, and these rigid structures lead to what is a higher glass transition temperature for your polymers, which means if you heat them, the glass transition temperature is the temperature at which, if you go above that, the polymer loses its shape. So if you have a PET bottle, this is 75 degrees more or less. If you put hot water of over 75 degrees in it, it will shrivel. This is an issue with a lot of reuse applications, and it's very difficult to overcome with traditional oil-based monomers. And also this increased functionality also allows probably for design degradability. That's some of the research we've been doing in that field indicate this. So I would like to thank you for listening to my presentation. And if you have any questions, you can maybe send me an email, or there may be time later to ask them. And then I would like to give the floor to Fabiola. Thank you.
Thank you very much, Robert, for your presentation. If you have any questions for Robert, please contact directly him by email. And now, last presentation for this webinar. I'm making Miriam the presenter. We will present the last presentation together, but I'm happy to leave the floor to her.
Good morning, everybody. Let me know if you can see my screen.
Yes, but not in presentation mode.
Okay, give me 1 second. Okay.
Now, yes.
Can you see it now?
Yes, thank you.
So, thank you very much. So, good morning, everybody. My name is Miriam Lorenzo from Hera Holding. I'm happy to be here to have a little talk with you about the stakeholders' activities. This is the outline of this short presentation. I will give you a general overview about the stakeholders' activities as you as an audience. I will talk a little bit about work package number 1 objective and working plan, and then I will leave the floor to Fabiola to expand the information about the developed methodology and other potential benefits for participants and ongoing activities. Let me start by explaining how these type of projects are organized. It was already mentioned by Raul, but we are organizing COSMOS project at most of the Horizon 2020 projects in work packages having specific objectives, common objectives. We are going to be focusing the work package number 1 because this work package is directly dealing with the relationship with stakeholders. As you as an audience. As you can see here, this work package is aiming to provide quality information for other work packages, specifically the scientific work packages. So in this moment, in these activities, the feedback from stakeholders is very important. When we talk about stakeholders, we are not only talking about the stakeholders directly involved in the COSMOS project, such as Avantium. We have a lot of feedback from them, but also all the relevant actors in the whole value chain of this CO2 to bio-based product long value chain. So we are talking about technology providers, final industrial end users, feedstock suppliers such as CO2 emitters, refineries, and so on. So as I have already commented, our main objective in work package number 1 is to provide information, quantitative and qualitative information to other work packages in the COSMOS. Well, talking about a little bit more on detail about this work package number 1 objectives, and if you allow me this simplification of what we are going to do here, as Raul already commented in detail, we are going to take the biogenic CO2 coming from the bio-based industries together in some transformations together with bio-based feedstock that it is going to be used as catalyzers. These ingredients are going to follow specific pathway, specific biochemical, chemical, green chemical, or electrochemical pathway to be transformed in add value products to be reintroduced into the BBI industry again, or why not in other sectors, giving this line the sense of circularity, the shape of a loop. So having this picture in mind, what we are going to do is to establish the requirements or the feedback for each step of the value chain regarding the stakeholders' feedback. In this sense, the first objective will be to define the stakeholder requirements in this part, in the right side of the pictures, requirements and specifications for the key components that we are going to produce. We will evaluate the type of emissions, not only biogenic CO2, but also this bio-based feedstock that it is going to be utilized or transformed together with the CO2. We will determine the key indicators in terms of performance, impact, and socioeconomic. And finally, we will identify the overall process value chain that enables the optimal performance and efficiency of this process. Well, how are we supposed to do that? We are organized in specific tasks. We have 6 groups of tasks. They are running in parallel because we are, and they started from the very beginning of the project because we are the preparatory activities for the rest activities scheduled in this Cosmos project. And at this moment now, we are focused in this task 1.1 and 1.4. They are directly related with the stakeholders' activities. And here we are mainly focusing this task 1.1, elicitation of stakeholder requirements and market needs. And here, in the right side of the table, you can find what we expect to obtain or what we expect to perform in shape or in the form of deliverables to be submitted to the European Union. So when talking about task point 1, this is the elicitation of stakeholder requirements and market needs. Main objective of this activity is to identify stakeholders and their requirements and specifications. These requirements and specifications will become, of course, measurable requirements when possible. They will be need or updated because we have a preliminary vision in the proposal of this project, and they will be translated into KPIs, that is, key performance indicators in the field of in the technical, economical, and environmental and social field. Not only they will be technical or economical. In this sense, we have already developed and submitted to the European Union this deliverable 1.1. It is called Design Thinking Session Manual for Materials and Materials for Cosmos. This is a tool, an active tool. It will be explained later on by Fabiola, and this is going to guide the interaction of this Cosmos project, this work package number 1, with the stakeholders of the project. What we are going to develop is the qualitative information in this deliverable 1.2, which is called Stakeholder Requirement and Market Needs, and key performance indicators, selected indicators will be reported in deliverable 1.3. And at this point, I'm going to give the floor to Fabiola to go more on detail on this methodology and how are we going to interact with you, the stakeholders of the project. Thank you very much.
Thank you, Miriam. Thank you very much. So, yes, I take the floor because Rina is the deliverable leader of this first deliverable of the project. And we think that it was important to understand and to develop a methodology to identify and also interact with the project stakeholder. That, as Miriam said, are not only the project, the stakeholders already in the consortium, so for example, Avantium, but also other stakeholders outside. So starting from this sentence, the main objective in the development of this methodology are, of course, first of all, identify the players. The key players of the project that could be later on the new potential industry and potential stakeholder. So identify them, engage them, so start the first interaction with them, maybe also thanks to, for example, this webinar later on, I will explain you the methodology that we developed. Define stakeholder requirements and the specification to characterize the industrial vision regarding circularity, of course, and also regenerative capacity of the biogenic CO2 emission into added value chemicals. After that, this information will be useful for preliminary estimated circularity and the regenerative capacity potential of the industrial value chain developing in Cosmos. And also the idea is to drive Cosmos research and development activities in terms of Cosmos process development and design. So basically, this first deliverable started, the first chapter of this deliverable was the target, so the identification of the stakeholders. So the activities started also during the proposal phase. The the project. So we can already find in the grant agreement, so the official contract that the consortium have with the European Commission, a preliminary list. Thanks also to CARTIF, we cooperate. We try to finalize this list, identifying which are the potential end user or key players, as you can see also in the slide, and also based on the technology that Raul explained you before. And of course, also to try to identify the potential industries and BBIs and users as a potential stakeholder. So biogenic CO2 producer with potential application as a carbon source for COSMOS technologies, feedstock supplier as a raw material for bio-based process and products, and also bio-based industry focus on bioproducts development and as end user of the COSMOS technologies. Please, Miriam, go ahead. Next slide. Okay, thank you. So basically, we started, we identified the stakeholders, but now we had to think about how we can engage the stakeholders. So basically, we started from two questions. So in order to emphasize the expected benefit from the COSMOS CO2 chemical platform concept, which are the industrial stakeholders' requirements and specifications? And the second one was, in order to preliminarily estimate the circularity and the regenerative capacity potential of the industrial value chain developed in COSMOS, how could the COSMOS innovative, cost-competitive CO2 conversion technology be integrated into existing industrial processes? So, of course, we can try to answer, but it's better to have a clear review also thanks your opinion. So for this reason, the methodology that we developed for Engage You was this one. So we started from this webinar, the first webinar, where of course the goal is to present the project, present the activities that we have to perform during the years of the project, and also to invite you to submit a survey online. Later on, I will send you the link. Also to give us an overview, your vision of the sector. Of course, as I said, not only you are potential stakeholder, but external stakeholder of the consortium, external from the consortium. But for us, it's important also to create a deep way, deep communication with the consortium stakeholder, consortium user case. So we will organize in parallel also questionnaire, face-to-face interview with the partner, Avantium and Novamont, basically, to understand and deeply understand their needs. And after that, we will organize a second webinar in the middle of October, where we try to summarize, of course, the results of the survey and the results of the questionnaires with the COSMOS end user, and to show you the results that we received. And of course, thanks to the live polls, the idea is to try to validate these results. So we're really glad to have you again in the next webinar as an attendee. Go next slide, please. Okay. So what about the survey? So as I said, the survey, the idea starting from the needs to analyze the end user requirements. In order to understand how the technology, the COSMOS technology, could be applied in a different sector, industrial sector. So we prepared this survey. Of course, also considering the GDPR policy, we prepared this the survey accordingly. So we used the Microsoft form where the GDPR policy is sure. So basically, we follow the instruction to be sure that your personal data are saved. So I'm glad to invite you to participate in the survey. So next slide, please, Miriam. No, sorry, okay, thank you. So we have these needs for the survey, but of course, my question, I had the question in my head, why the attendees of this webinar have to want to help us, to join us in this project. So basically, Cosmos have, of course, some objectives, but for us it's important also to understand that these objectives are closer to the industry needs and perspective. So in some way, if something will emerge from this survey and from the questionnaires, and also maybe from the questions that maybe you are writing to us in this webinar, we can try in some way to cover and to reach this objective in this project. And also because Rina is the VP leader of Work Package 6 related to the replicability studies, market analysis, regulatory framework, and social acceptance measurement. So in some way you could become a new, let me say, a new demonstrator of the project. Maybe after the project, but also during the last part of the project, maybe we can start and interact with you, also to define, understand if in some way we can replicate this project in your industry, in your business. So this is why we are preparing this survey, and why we hope you are happy to join us. So in the next slide, you can find the QR code that you can scan with your phone to participate, to fill in the survey. And also I'm just sending you in the chat the link. So in some way you can if you prefer, you can click or you can scan the QR code in the screen of your computer, your PC. So of course, we will not close the survey today. We will leave the survey open, I think, by the end of September. So you can spend time also to fill in to answer the questions. So thank you very much. I hope to be clear. If you have any questions, of course, I'm here. Also, Miriam and also other partner, I think that would be happy to answer. For the last part of the webinar, we prepared 3 simple questions related to the presentation that we done. So if you can, I think that now you can see the first questions related to, are you already participating in a European and international initiative, for example, H2020, or now there is the new European funding schemes that is Horizon Europe, so maybe you are now participant, maybe not. So let us know. I can leave this question open for maybe some minutes. Okay, thank you. I can see some that the answer is coming. So more than 55% are working on right now on the project, H2020 project or Horizon Europe project or other international initiative, and also they work in the past. Someone no, neither in the past or now. Okay, I can leave the question open for some minutes more. Okay, so, okay, thank you. I can close the answer, the question and your answer. So more than 56% of you are working on right now, and also in the past work on H2020 project or other international initiatives. So great for this answer. Okay, I can close this one. Okay. Okay. Now the second one. Okay. Have you already carried out studies on the environmental and economic impacts of your process? Also for this one, I can leave the question open for a minute. Thank you for the answer. Okay, thank you very much for the answer. I can see that some of you had studies that show good performance but can be improved. Someone else, no study available. So very interesting. Thank you very much for the answer. Okay, now I'm closing this one. Okay, and the last one. Can COSMOS technology focus on covering CO2, green hydrogen into added value chemicals to adapt it to your sector business? Yes, no? Okay, we can wait some second more. So I'm happy to see that 95% of you answer yes. So in some way you could be a potential external stakeholder for future replication of the project. So happy to see that. Thank you very much. I'm closing the last question. Okay, so thank you very much for joining the webinar. We received some questions also in the question and answer panel, so I'm happy to read all of that to the panelists. So I also open. So if I don't know, Raul or other partners want to answer, please unmute your microphone. So first of all, the first question is, at what scale is this project working on?
This is a question I can answer. Thank you.
Thank you.
To which scale? Well, this project will be validated at pilot plant scale. It's not a demonstration project, so the products we are going to, the end products we are going to produce are not going directly used in the market, but all the processing from the laboratory to the pilot plant scale is going to be performed and validated at this scale, even though we are going to test some of the building blocks or target molecules, the CO2 or bio-based intermediate materials. We are going to test it into a real formulation in Novamont, in Avantium, but at laboratory scale, and further develop at a kind of pilot facility as well. But we are not going to reach demonstration or market scale in this project. This is a research and innovation action. So this is our top limit. Okay.
Okay, thank you, Raul. Thank you very much. So the second one is, will cradle-to-grave life cycle assessment across the entire value chain be undertaken as a part of the COSMOS project?
But this is another question I can answer as well. Yes, our idea is to perform the life cycle assessment not along the whole process, from the CO2 to the end products, but to focus on the first part of the process, when starting from the CO2 and the hydrogen and producing the building blocks. Talking about monomers, the PHE, the butanediol, and so on. This is our limit of battery in principle to perform the whole life cycle assessment, because this is the most innovative part of the project, and they will bring us better results. Of course, we could extend the life cycle assessment to the whole value chain, from the CO2 capture and utilization to the end products formulation. But the results will not be so representative, because in the last part of the process, it is not so innovative in terms of reaction processes and so on. We are going indeed to replace the fossil fuel, the standard chemicals that we use in the final formulation of the polymers, by these new CO2-based intermediate products. So just a way of simplifying the analysis and focus on the real innovative and the real low carbon technologies that we are going to develop. Okay, thank you.
Thank you. Thank you.
If we allow me to add something regarding the life cycle assessment, because I think this is a specific question for the responsible, but they are not speakers today. So I'm going to give my point of view from inside the project. We are going to develop technology to produce specific add value chemicals to be counterparts from fossil products. So it has no sense to open the battery limit to the downstream process, because it is going to be similar, common. So we can compare the specific product that we are going to produce with their equivalent counterpart. So this is why your scope of the project, the scope of the project is like this: from cradle to grave, or no, it's not to grave indeed, it's cradle to gate, let's say.
Okay, thank you very much, Raul and Miriam, for the answer. Another question related to will the webinar slide be shared afterwards? I can answer directly. This webinar is being recorded, so we will publish the recording in YouTube, I think. I have to ask to Lara maybe if you want to add something, but of course we can watch the webinar, so of course you can see again what we presented.
Sure, the recording will be sent to the participants, so that's not a problem. Once it is online, we will share it with you and on our social media too.
Okay, thank you very much. So another question, in the COSMOS project, do you investigate the potential value adding of CO2 through carbon credit, for example, voluntary credit? Maybe Raul, if you want to answer.
Well, in principle, this is not This is not one of the main targets of the project.
Okay.
The target of the project is using CO2 as a raw material, not adding CO2 to other processing like co-processing. So starting from CO2 as a carbon source and then convert it into acetate and develop the whole process. So there's a possibility, but we prefer to focus on the core of the technologies, that is conversion of CO2 into chemicals.
Okay, thank you, Raul. So another question, are coming a lot of questions. I try to read all of them. So about question about the polymers from CO2SMOS. Are you going to tackle the process of converting cycle carbonates into polycarbonates? If yes, how and using which catalyst? I don't know again.
Sorry. Yeah. So yeah. So we are also working on that, but I had only a relatively short presentation, so I focused on the majority of the work we'll be doing. So we will also indeed be working on the conversion of cyclic carbonates to polycarbonates. But at this point, I can't really say what kind of catalyst we're going to use, because we don't know yet exactly, because we have a selection of cyclic carbonates that we're going to work on, but we do not yet know.
Okay, thank you. Last two questions. One is coming from Anton. I'm working in oil and gas industry sector. In the upstream, do you think that CO2SMOS can be applied to reduce carbon emission from oil and gas? So, for example, by implementing this green technology for material used for upstream, also would you consider blue hydrogen as a source for your production value chain?
Yes, Fabiola, can you say again, please? Sorry.
Yes, of course. So, Anton works in the oil and gas industry sector, in the upstream. The question is, do you think that CO2SMOS can be applied to reduce carbon emission from oil and gas? For example, Anton proposed an example. For example, by implementing these green technologies for materials used for upstreams. Also, would you consider blue hydrogen as a source for your production value chain?
Well, the answer is that the source of hydrogen is not a bottleneck of the project. We aim for renewable hydrogen, green hydrogen, but as long as other types of hydrogen, such as blue hydrogen or another kind of upstream processing, can be implemented, I think that yes, it can fully complement the project. It's not a focus, but I mean, this project is about toolbox of technologies, and one of them is using renewable hydrogen. No matter the type of hydrogen, we are focused on green hydrogen, but we can start from another types of gases as well. The only thing we need is a source of protons to convert CO2 into chemicals as much renewable as possible. But that's the point, yeah.
Okay, thank you very much, Robert. So the last one, and after that we will close the meeting, the webinar. CO2SMOS focus on CO2-to-Chemicals. Second, third generation e-fuel could be part of the value chain. Can you please comment the synergy among these options?
If I understood well, the question is about generation, about energy generation.
Generation e-fuel could be part of the value chain.
All right. This project is not focused on biofuel applications. It's focused on biochemicals for the chemistry sector, polymer and renewable chemical sector. Of course, the core of the technologies can be adapted for fuel, for clean fuel production as well. As long as we have converted CO2 into acetate, we can develop an alternative process to produce via fermentation, for instance, lipids or a kind of diesel-like product. Indeed, there is a H2020 project we are participating in that is called Biosphere, that is taking this concept of using the gas fermentation process to convert CO2 and hydrogen into acetate and then into lipids that can be further hydrogenated and upgraded to fuels for aviation and maritime applications. So these toolbox of technologies are compatible with other applications, but in this specific project, we are going to focus on chemicals, and the chemicals we have already selected, because the final application is focused on polymers and basically polymers and chemistry products, chemical products.
Thank you very much, Raul. So thank you very much to all the attendees. I hope that interesting the webinar. So then basically, please complete and fill in the survey if you want, and see you in next time for the next webinar in October. So thank you very much also to all the speakers, the colleagues that attended the meeting, and well, have a nice day. Thank you.
Bye, everyone.
Thank you.
Thank you. Bye bye.
Thank you.
Bye.
Bye. Have a nice day.
Have a nice day. Bye bye.
Bye bye.